AP Statistics, Section 1.2, Part 1. Hey class, today we're going to be talking about dot plots and stem plots. So let's get right into the presentation. Okay, so the last couple of lessons were on categorical data. Today, what we're going to be talking about is we're going to be talking about quantitative data. Okay? So as a review, right, section 1.1 was on categorical data. This time we're going to be talking about quantitative data and how we display it. And section 1.3 is how are we going to analyze that data or display it as numbers, okay? Describe it with numbers. But for now, we're just going to talk about how we display quantitative data with graphs. So by the end of today, you should be good with the first three of these, okay? Number one, you should know how to construct and interpret dot plots, stem plots, and histograms. You should also be able to describe the shape of any type of distribution, and you should also be able to compare them. Okay, one of the simplest graphs that are used to display quantitative data is a dot plot, okay? And essentially, each dot in the plot represents one of the values, okay? So how do you make a dot plot? Well, first, you draw a horizontal axis, right? And you make some sort of number line with the values of your variable. Then you scale the axis appropriately, minimum to the maximum value. Then you mark each dot above the location of where it is on this horizontal axis. So, for example, let's say we were looking at the data of the number of goals scored per game by the 2004 women's U.S. soccer team. Okay? Each of these represents a game, right? The 3, the 0, the 2, the 7, 8. The number of goals scored in that game. Okay? If we were to make a dot plot of this, it would look something like this, right? This 0 is that one game where they scored 0. These ones are what? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of them right here, right? And twos, 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, so on and so forth, right? As you can see, it's labeled. You always need to label it, because if you don't label it, then we have no idea what it means, okay? So it's the number of goals scored, and then each dot represents the number of goals scored in a particular game, okay? That's how you create a dot plot. Okay. All right. So when you are looking at a quantitative variable, you want to look at like what you see, right? You want to describe what you see. How do we describe it? Well, we want to look at the overall pattern, right? And how we're going to describe the pattern in this class is shape, center, spread, and outliers. You want to make sure that you remember this. Shape, center, spread, and outliers. Okay? Or in other words, don't forget your socks. S-O-C-S. Socks. Okay? This is probably one of the most important acronyms of this chapter, because you're going to be given distributions that you need to describe. Okay? How do I do this? Well, if I look at this dot plot right here, we were talking about this data the other day, about the cars and the miles per gallon that they get, right? This 14 is the Bentley, this 18, right, is the Rolls Royce, right? And how would I describe this data, right? Okay, well, if I were to describe it using shape, center, spread, and outlier, then what I would say is something along, or actually, normally I'd have you describe it first, but now you can't. So, what you would want to say about the shape is whether it's symmetric, or it's skewed right, or it's skewed left. What does this mean? Well, symmetric means, well, it's, there's roughly around the same amount of data to the left as there is to the right of what you kind of deem to be the center of the data. Okay? A distribution is skewed to the right, okay, if the tail trails to the right. So in other words, there's like a hump, and then there's the tail that trails to the right, okay? It's skewed to the left if it has a tail that's to the left, okay? So this one right here is skewed left, this one right here is skewed right, and this one is relatively symmetric, okay? Okay, so if we were to look back at this data, right, the shape of it would be slightly skewed to the left, right, with a center of probably, like you could use the median, right? I don't know how many there are here. So if I were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So the 12th data point is probably the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, the 12th and 13th point, which are both 28. So the center is at approximately 28. It's skewed to the left. The spread is the range of the data. So 14 to 33, right? And 33 minus 14 is, oh wow. 33 minus 14 is 19. So the range is 19. Okay? So the range is 19 miles per gallon, and there might be an outlier at 14 and 18. That is your SOX. Shape, center, spread, outlier. Okay? So, if you are comparing distributions, you don't want to forget your SOX, right? So this is what? The average household size in the UK versus in South Africa. Okay? So you have your shape, center, spread, outliers, okay, for both of these. So what you could say, and I can't believe, oh, they don't have it here. What you would do is you would say what? The shape of South Africa is skewed to the left, whereas the shape of the UK is relatively symmetric. The center for South Africa is probably around 6 per household. 6. Yeah, probably 6 per household. Whereas with the UK, it's probably around 4, right? Using the median of the data. Okay? The spread for families in South Africa is somewhere around 20, and for the UK, it's around 5. And that's how you would compare your shape, center, spread, outlier. Okay. Your stem plots and your, so the next thing that we're going to talk about is stem plots. Okay? Your stem plots, right, how you create them is essentially you have a stem and then you have a leaf. Okay? What does this look like? If you have, let's say I asked all of you, how many pairs of shoes do you have? Okay? Well, this is like incredibly boring. But okay, we're just gonna go through it. We're gonna try it, okay? So how many pairs of shoes do you have? And I ask you to construct a stem plot of this. What this would look like is you would put your stems representing the tens place in all of these areas. And then the leaves, which is what? The ones place, okay? So in other words, this and this, 1, 9, that represents the person who said they had 19 shoes. Okay? The 1, 3 is someone who says they have 13 shoes. And this is what a stem plot would look like. Now, you want to write them in order, right? So it'd be what? 13, 13, 13, 15, 19, so on and so forth. Okay? And then you add a key to represent the number of students within each leaf. Okay? Okay. A splitting stems, back-to-back stem plots, right? Let's say you ask males the same question. Okay? Well, split stems makes it easier to see. So in other words, 0 through, I believe, 5, and then what? 6 through 9 would go on the opposite stem. So in other words, for males right here, 0, 4, the person who has 4 shoes versus 5 shoes, you're going to put them in 2 different stems. Okay, so this is the stem plot for males. And this is the stem plot for females. You put them back to back. What this is good for is so that you can compare them one on top of the other. Okay? So what it would be for your socks here would be, males would be what? Skewed to the right. The shape is skewed to the right. A center of like probably around 7 pairs of shoes, right? For females is probably the center is around 26. It is relatively symmetric. The shape center spread, the range for males is 34, and the range for females is whatever 57 minus 13 is, which is, oh my goodness, sorry, 34. That's the range. And that's how you would compare them. The video can't be much longer than this. I don't actually think that this was a good video, but we're going to give it a shot. Have a good day.